Hello and welcome to the walking talking topic on vectors, question number 6 with me, Mr. Barton. Right, a reasonably difficult vectors question here, but as long as we use the techniques that we've used throughout the previous 5 questions, we'll be absolutely fine. OPQ is a triangle, R is the midpoint of O to P, there it is there. S is the midpoint of P to Q, there it is there. O to P equals P, O to Q equals Q, and the first bit, find O to S in terms of P and Q. So we've got to get from O to S. Which way could we go? Well, we can't go this way. It's direct. We don't know it. Can we go this way? O to Q? Yep, fine. Q to S? We don't know that bit. Let's try the other way. O to P? Yep, fine. We know that. P to S? Don't know it. So this is the first vectors question that we've had in this series of videos where we haven't been able to do part A straight away. But that's okay. Let's work out how to get from P to Q. And then because we know S is the midpoint, we know it's halfway. So let's get P to Q boxed off first. To get from P to Q, I'm going to have to start at P and I'm going to have to dip into O because I know that, and then come out from O to Q. So I'm going to go P to O, and then when I get there, I'm going to go from O to Q. P to O, that is going the opposite way that arrow is pointing, so it's going to be minus P, and then O to Q is going to be a positive Q. So there you go, there's P to Q sorted. So how does P to S relate to that? Well, P to S is going to be 1/2 of what P to Q is. So it's going to be 1/2 of minus P plus a Q. Now, as long as you're good at your multiplying out, you'll be fine here. 1/2 of minus P is going to be minus 1/2 P. That's 1/2 of a whole of negative P. And then 1/2 of positive Q is going to be 1/2 of Q. So that gets me from P to S. Now, I've not answered the question yet, but all that is going to be very important for later on. So now to get from O to S, well, now we can go from O to P and P to S because we've got both of those. So to get from O to S, I'm going to go O to P, and then when I get there, I'm going to go from P to S. O to P, that's just going to be vector P. P to S is going to be, well, we've got it down there. That's going to be plus minus 1/2 of P plus 1/2 of Q. So we've got P, add on minus 1/2 of P, that's just going to leave me with 1/2 of P, and then I've got 1/2 Q to add on as well, 1/2 of Q. Now, I know it says up here, diagram not accurately drawn, but you can still get a sense of roughly whether you're right there. We're claiming if we start at O, if we go 1/2 of P, and then we go 1/2 of Q, we end up at S. That seems to be about right to me. That's looking quite good. Okay, next bit. Show that R to S is parallel to O to Q. Now you can see it looks like it's going to be parallel, but that's no good to anybody. We've got to find the vector R to S, find the vector O to Q, and show that they're parallel. So how are we going to get vector R to S? Well, I think our best bet is to go R to P and then come down here P to S because we've got both of those. So let's go R to P, then when we get it to P, come down P to S. What's R to P? Well, O to P is P, and R's halfway in the middle, so that's just going to be 1/2 P. And then let's get from P to S. Well, we had that before. That's minus 1/2 of P plus 1/2 of Q. Sorry, I know you can't quite see that, so we had that before. P to S, minus 1/2 of P plus 1/2 of Q. Let's tidy that up. 1/2 P take off 1/2 P, gone. Just leaves me with 1/2 of Q. So that's RS. What was OQ? OQ, well, that's just Q. We know that from there. So we've got, that's 1/2 Q, that's Q. Well, we've pretty much shown the parallel there. Therefore, they are parallel. You don't really need to state much more. Some people like to write this one as this, 1/2 brackets of Q, and show that that is kind of 1 bracket Q. But, I mean, flipping heck. Q and 1/2 Q, they're going in the same direction. They both got Q there. Just that one is twice as long as that one. Done and dusted. I'll take the marks. Thank you very much.